I think I messed up. I thought building a CPU was just a matter of putting some parts together, maybe a few wires, a bit of metal, and voila, a computer brain. But wow, was I wrong. The reality is so much more mind-blowing and complex than I ever imagined. The journey from raw materials to the tiny chip that powers your phone or laptop is a story of science, engineering, and a little bit of magic. I had no idea how insane making a CPU actually is. These factories, called fabs, are some of the most advanced places on Earth. They're filled with machines that cost millions of dollars, running 24/7, and staffed by engineers in head-to-toe clean suits. Every step is controlled down to the tiniest detail, because even a single speck of dust can ruin everything. It's way more complicated than you'd expect. The people who work here are like modern-day alchemists, turning something as ordinary as sand into the beating heart of your computer. They use tools and techniques that sound like science fiction, lasers, robots, and chemicals with names you can barely pronounce. First up, sand. Yep, the main ingredient is super pure silicon, usually made from sand. But not just any sand. This is quartz sand, and it has to be almost perfectly pure, 99.9999% or better. Any impurities, and the whole process falls apart. It's wild to think that the same stuff you find at the beach is the starting point for the world's most advanced technology. This silicon gets melted down at temperatures over 1400 degrees Celsius and turned into giant crystals called ingots. The process is called the Czochralski method, and it involves dipping a tiny seed crystal into the molten silicon and slowly pulling it out while spinning it. Over hours, this forms a single, flawless cylinder of silicon. Imagine a shiny cylinder, taller than you, weighing hundreds of pounds. This is the raw material for every CPU in the world. It's almost like a work of art, smooth, reflective, and impossibly pure. But we're just getting started. That giant ingot is sliced up with a diamond saw into super thin wafers, thinner than a piece of paper. Each wafer is polished until it's as smooth as glass, because even the tiniest scratch could ruin the circuits we're about to make. Next, we slice that crystal into super thin wafers, thinner than a piece of paper. These wafers are so delicate that they're handled with special tools and gloves, and they're inspected under powerful microscopes to make sure they're perfect. Now here's where the magic happens. The wafer is cleaned, coated, and prepared for the next step, photolithography. This is where the real wizardry begins, and where the patterns that will become millions of transistors are created. We use light to print tiny circuit patterns onto the wafer. It's like taking a photograph, but instead of capturing an image, we're creating the blueprint for an entire computer chip. Ultraviolet light shines through a mask, projecting the intricate design onto a light-sensitive coating on the wafer. It's like using a stencil, but the designs are thousands of times smaller than a human hair. The level of precision is mind-boggling. Lines just a few nanometers wide, packed together in patterns so dense that billions can fit on a single chip. But printing the pattern is just the beginning. Now comes the chemistry, layers upon layers of material.